Hello, welcome to all to another lecture, which is one of the section things. So, we are going to discuss some numericals related to current electricity. Okay, we have to go through the chapter very precisely so that we can solve the numericals. First question: a flow of 10 to the power 7 electrons per second in conducting wire constitutes the current of. So, we have to find what and current. Okay. Now we know there is 10 to the power 7 electrons per second. That means if A is the number of electrons and number of electrons is per second n by t, we get 10 to the power 7. From the question we get number of electrons per second is 10 to the power 7. We know current equal to amount of charge reached to a conductor divided by time per second. Amount of current reached to a conductor per second. And again, we know if there is n number of electrons, and charge of each electron, E. So total charge will be in E, where A is the number of electrons and we are indifferent. So we can put the value of Q equal to N using N E divided by T. Now we know N by T is 10 to the power 7. And what is the charge of electron? We know charge of electron is basically 1.6 into 10 to the power minus 19. And charge of electron will be negative. So 1.6 into 10 to the power minus 19 coulomb will give the value of charge of electron. So on the value of charge of electron is 1.6 into the power minus 19. So what should be the result? 1.6 into 10 to the power minus 12. Left hand side there is current, so the result will be having. Is it clear? So move on to the next problem. Circuit is given and you have to find the magnitude and the direction of the current. First of all, we have to know the direction of the current. There is, if you take this physical 8 volt, this is 10 volt. So basically current flow from positive to negative, that is, if you compare this 10 volt and 5 volt, so net EMF will be what? 10 minus 5, so 5 volt. And direction will be from positive to negative. This has the greater value. So this EMF will control the current. So current always comes from the positive side because electron moves from negative to positive. So current will move from positive to negative. So this will be the direction. So what will be the direction of current from A to E to B? So direction will be in the direction. Direction will be from A to B via E. A to B via E. This will be the direction. Okay. Now we have to find the magnitude of the current. That means we have to find value of I. If you take the net image that is get 5. Okay. Or we can take like this, and total resistance is basically node are in series connection. So, and if you take the current, let's say I, current is flowing. So total resistance equivalent will be sum of all the resistors because they are in series connection. So 2 ohm plus 1 ohm plus 7 ohms. So the total result will be 10 ohms. And if you find the current from Ohm's law, I equal to V by R, equivalent, V is equal to V, or you can say EMF is basically 5 volt, resistance is basically 10 ohm. So if you calculate this, so you will get R ampere 0.5, and this will be the resistance. This is clear. Now move on to the next problem. Combination of resistance is given. So we have to find the equivalent resistance. So between A and B, so we have to find the equivalent resistance between this and this. So we will start from here and we will move on in this line, like this clockwise direction. So if we take 3 ohm and 3 ohm, these are basically series connection. So this will give you 6 ohm. These two resistance will give you 6 ohm. Since they are series connection. Now this 6 ohm, this 6 ohm connection will be parallel connection because they are getting same. Both the names will be the same. So this 6 ohm and this 6 ohm, this 6 and this 6 is to be in parallel combination. So from this you can get 6 6 6 plus 6 for parallel combination. If there is two resistors, you can use the formula I1 I2 by I1 plus I2. So what is the result? 36 by 12. So result will be 3 ohm. So from here we get 3 ohm. Again, this 3 and 3 is series connection, so result will be 6 ohm. This 6 and 6 will be parallel connection, so again it will give you 3 ohm. This 3 and 3 in series connection, so 3 and 3, 6. Again, this 6 ohm and this 6 ohm in parallel connection, so give again 3 ohm. This 3 ohm and this 3 ohm in series connection, so total 6 ohm, you get 6 ohm. This 6 ohm and this 3 ohm is parallel connection, so total IP equal to total IP equivalent. That is, you have to find IP equivalent. This 6 ohm and 3 ohm parallel connection, so result will be EG divided by 9. So very important problems that it will be given like that. If you like combination, revenue, and you have to find the equivalent resistance. So this type of problem is in example. Okay.